Students, next we are going to discuss the topic cyclotron. Now, cyclotron is a machine. It was invented in 1934 by M.S. Livingston and E.O. Lawrence. Now, this machine is used to accelerate charged particles like proton, alpha particles, etc. to very high energy. This is the aim of cyclotron. It is a device used to accelerate charged particles like protons, alpha particles to very high energy. Now, this is done with the help of a combined electric and magnetic field, or we can say a cross field. You know, if there is an electric field, positive, negative, if there is an electric field and if a charged particles enters the field, what happens? It experiences a force given by F is equal to Q E, or acceleration A is equal to QE by M. So, the velocity of the particle in the field is V is equal to U plus AT, which becomes, imagine our particle initially is at rest. So, U is equal to 0. So, V is equal to, instead of A, QE by M into T, which means if you increase the field or if you increase the time for which the particle is travelling in the field, you can increase the velocity of the particle and hence its kinetic energy can be increased. But how can we increase the velocity? By changing the time span. What do you have to do? You apply a potential to a larger distance. So, field direction is from positive to negative. So, if you increase the field distance, what happens? Automatically time taken by the charged particle to move to the field increases and hence velocity can be increased. But there is one problem, you know that E is equal to V divided by L, potential by length. So, if length increases, what happens? Effect will decrease. So, there is a problem here. So, what we have to do is we have to increase the velocity or kinetic energy of a charged particle. So, what we do here is we make the charged particle move through the field a repeated n number of times, and this can be achieved with the help of a magnetic field. Now, you know, when a charged particle passes through a magnetic field, depending upon the initial angle, it will experience a force and that force will alter the path of the particle. So, why can't we use a magnetic field to increase the energy of the particle? I told you we are using the combined field, that is electric field and magnetic field are perpendicular to each other. When a particle enters perpendicular to the magnetic field, what happens? It executes a circular path and the direction of magnetic force will be towards the center of the circle. So, imagine my particle is travelling in this path. So, at this point velocity will be tangent to it. This is velocity, this is force, the angle between them is 90 degree. You know that work done is equal to Fd cos theta. Direction of displacement and direction of velocity is always the same. So, the angle between displacement and force is 90 degrees. So, what happens to work? Work becomes equal to 0 since cos 90 is 0, which means a particle moving in a magnetic field does not do any work, does not experience any work. And according to work energy theorem, change in kinetic energy is equal to work done. Here work done is 0. So, definitely kinetic energy is also equal to 0. So, with the help of a combined electric and magnetic field, we increase or we accelerate a charged particle, and this is the principle of a cyclotron. Now, a charged particle can be accelerated to a very high energy by making it pass through a moderate electric field number of times. And how we make them pass a number of times? with the help of a magnetic field, and this can be achieved with the help of a perpendicular magnetic field which throws the charged particle into a circular motion, the frequency of which does not depend on the speed of the particle and the radius of the circular path. Next, let us see which are the parts of a cyclotron. So, there must be an electric field, there must be a magnetic field. If you look into this diagram, you can see there are two D-shaped metal plates, and these D-shaped metal plates are known by the name beads. Because it is a D shape, it is known by the name beads. It is a metal plate, and to the metal plate we have applied an high frequency oscillator or a AC current. Now, what is the specialty of AC current? You know, it has a positive side and a negative side. So, at an instant of time, one side of the D means D1 will be positive. That time the next D2 will be negative. And after a fraction of time, what happens? The polarity of the oscillator reverses. So, this D1 becomes positive and D2 becomes negative, and this keeps on repeating. Now, this bead is placed in the presence of a powerful magnet with the help of electromagnet. Now, the electromagnet's field is from north to south. So, the field is perpendicular to the bead, and there is a small deflection plate at the edge of the bead through which our charged or accelerated charge particle comes out and hits the target. Now, we are going to see how our cyclotron is going to work. So, working of a cyclotron. So, imagine the particle to be accelerated is kept at the center of our bead, and initially the bead D2 is positive and D1 is negative. So, our charged particle, we are using a positively charged particle. So, what happens? Positively charged particle automatically get attracted towards the negative side, and there is a field here. So, when it is getting attracted, the charged particle starts to move towards the D1 with a force. Now, once it reaches the plate D1, it is a metal plate and there is electrostatic shielding, which means the field has no influence on the plate D1 and also D2. So, there won't be any force of electric field acting on the charged particle once it enters the bead D1. Now, there is a magnetic field acting perpendicular from north to south. So, what happens? Our charged particle is entering perpendicular to the magnetic field. So, when a charged particle enters perpendicular to magnetic field, what will happen? It will start to move in a circular path. So, with the velocity, it start to move in a circular path. Now, once it reaches the other end of the bead, the polarity of our oscillator will be reversed automatically, and what happens? D2 becomes negative and D1 becomes positive. So, again what happens? From the D1 the particle gets attracted towards the D2, and while it is passing from D1 to D2, it will be experiencing a force produced by the electric field. So, again the velocity will increase, it will reach D2. What happens? There is electrostatic shielding. So, no field effect of electric field, only magnetic field is there, again perpendicular to the bead. So, it will again execute a circular path, and this process will keep on repeating till our charged particle completes the entire bead, and at the end it comes out of the deflection plate and hits the target. Now, theory. You know that the particle is moving perpendicular to the external field, perpendicular to the external magnetic field. What happens? It experiences a magnetic Lorentz force which provides, and that Lorentz force will make the particle move in a circular path. So, which means centripetal force here is provided by our magnetic Lorentz force Q VB, or the radius of the path will be R is equal to MV divided by QB. Now, if you look into this equation, you can see as velocity increases, radius of the path is also increasing. You know, each time when the particle passes through the gap between the D, it is experiencing the force by the electric produced by the electric field, and automatically its velocity is keeping on increasing, and hence R will also keep on increasing. And once it completes the entire deed, it comes out of the deed and hits the target. And time period of the charged particle in the field is given by T is equal to 2 pi m divided by QB. And frequency of revolution is given by Fc, cyclotron frequency. Fc is equal to QB divided by 2 pi m. Now, this frequency is known as cyclotron frequency. So, let us see what are the applications of cyclotron. I told you cyclotron was a device created by Lorentz and Livingston in order to accelerate charged particles in nuclear reactors. You know, in nuclear reactors what we do is we make the nucleus bombard with a high energy charged particle. So, to bombard the high energy charged particle, to split the nucleus, we use a cyclotron. The second application is it is used to implement ions into solids to modify their properties. To modify the properties of solids and metals, we use cyclotron to create high energy charged particle. It is also used to produce radioactive isotopes which are used in hospitals for cancer treatment. But a cyclotron also has its own limitation. Now, the limitations are, I told you in the case we are using positively charged particle. We can never use a neutron, we can never accelerate a neutron using a cyclotron. Why? Because charge of the neutron is equal to 0. So, the force experienced by the neutron will be equal to 0. So, a cyclotron can be never used to accelerate neutron. And also, it cannot be used to accelerate electron because electron is having a lower mass. So, the particle won't be able to execute circular path in the deed. It will move away from that circular path. So, you can never use a cyclotron to accelerate electron because of its lesser mass. Next, we are going to calculate what is the kinetic energy or what is the energy of the charged particle moving in a cyclotron. We know that the equation for kinetic energy is half mv square. Now, the radius of the particle moving in a magnetic field given by R is equal to mv divided by qb, or velocity v is equal to qbr divided by m. So, the kinetic energy becomes, we will call it as K max, kinetic energy max is equal to half m q square b square r square divided by m square, which is equal to half q square b square r square divided by m. Now, this is the equation for the maximum energy gained by the particle in a cyclotron. Thank you.